In this circuit, we have 3 resistors of different values connected in series. How do we know they are in series? Because they connected one after the other, forming just one path and not multiple paths. Let's perform a small activity now. Close the plug key and note the ammeter reading with these 3 resistors connected in series. Let it be I amperes. Next, place the ammeter somewhere between resistors R1 and R2 and note its reading. Similarly, place it between R2 and R3 and note the reading. What you will notice is that the current will be I amperes in each case. Yes, the current is constant at every point in the circuit. It tells us that in a series combination of resistors, the current flowing is the same throughout. Okay, now let's remove the ammeters which are between the resistors and try out something else. Now insert a voltmeter across the start of the first resistor and the end of the third resistor. Now plug the key and note the potential difference across the resistors. Let's say it's V volts. Now take out the plug key and disconnect the voltmeter. Now we insert 3 voltmeters in the circuit like this, one across each of the resistors. Now we plug the key and measure the potential difference across each of the resistors. You will notice that the potential difference across each of the resistors is different. Let's call them V1, V2 and V3 respectively. Even though the voltages are different, you will notice that the potential difference V will be equal to the sum of the potential differences V1, V2 and V3. This helps us derive something very important. Look at the entire circuit first. The potential difference is V volts and the current flowing through it is I amperes. Let's say these 3 resistors together form a resistance R ohms. We still don't know what R is, but we've just assumed all 3 together to provide a resistance of R ohms in this circuit. So according to Ohm's law, we can say that the V is equal to I times R. This was the entire circuit. Can you try applying the Ohm's law to each resistor separately? It's easy. For the first resistor, the potential difference is V1 volts. The current flowing through it is I amperes and the value of the resistance is R1 ohms. Applying the Ohm's law for the first resistor, we get V1 equal to I times R1. Similarly, for the other 2 resistors, we apply the Ohm's law to get 2 more equations. Now we can substitute the values of V, V1, V2, V3 in the first equation to get the result we need. V is I times R, V1 is I times R1, V2 is I times R2, and V3 is I times R3. Dividing both sides by I, we get the value of R as this. What did we just get? When 2 or more resistors are connected in series, the overall combined resistance R is the sum of the individual resistances. Now you understand why the resistance increases when resistors are connected in series. It's because each resistor when added in series adds up to the previous resistance. As the resistors are connected in series, we call the overall resistance Rs. On a new page, let's quickly review resistors in series. Take this simple electric circuit with one resistor. What will happen if I add more resistors in series? The overall resistance will increase and the current in the circuit will decrease. The current flowing in the circuit will be the same at every point in the circuit. And the overall resistance will be the sum of the individual resistances. In the next lesson, we will solve interesting problems related to resistors connected in series.